Hello everyone. Today we're going to work on 9.1. So we are skipping 7 and 8. We're going to come back to that if we have time, but I absolutely did not want to miss the geometry parts of the book, and since school is going to be out sometime soon, I wanted to make sure we hit these next two chapters. So we're going to do chapter 9, then chapter 10, and then I'm probably going to try to combine the statistics and probability chapters into one mini lesson of some sort before the end of the year. Okay, so 9.1. Okay, so we're going to talk about circles. Circles are, they're fun. They're a very important part of math. They are basically, if you've ever seen a protractor, it's one of those things that kind of looks like it's got a point on it, and then there's like a little extension on it. At the end of that, it's got a pencil. And the reason that there's my drawing. I know you guys miss it. So the reason that they're able to use this is because if you put this little pointy part right in the center of a circle, then this part right here is the radius. Okay, see, this is called the radius. I know this is not the first time you've heard about it, so I'm going to kind of fly through it. Radius is halfway. So if we put our little dot there and then spread the pencil out to any specific radius and keep the center pinned down with the point of the pin here, and we spin it around, the radius will be the same and no matter where we go, and that makes a circle. So that is what makes a circle. Here's the vocabulary you need to know. Okay, what a circle is: the center, which is the center, the radius, which is halfway across, which we care about because it is, like I said, the point where you would put that protractor and spin it. And then the diameter is how far it is straight across through the center. Okay, so this doesn't always have to be directly. So this same thing could be drawn from here to here. It would be the same distance. From here to here, it would be the same distance. Okay, so it's important to know that it is as long as it goes through the center, your diameter would be the same distance. Okay, no matter which angle you go at. All right, so the radius is half of the diameter. That's important, and the diameter is twice the radius. Okay, so that will come in handy to know that. It's common sense, but just remembering that on some of the problems you have to do sometimes might help you to figure out what to do. Okay, so that's the basics of a circle. Okay, so now the distance around a circle. Okay, so when you're thinking of, remember we've talked about like a normal rectangle, okay, and I always told you guys the fence is the perimeter and the grass is the area. Okay, well, circumference is a fancy word for the perimeter of a circle. Okay, so all we're trying to figure out in a circumference is the perimeter all the way around the circle. How many steps would it take to walk all the way around it? Not necessarily what's shaded in the center. That would be the area, which we'll do in the next section. Okay, now oddly, we come up with this really cool, and everyone's heard of pi before, right? But it is it's pretty cool. All the different places that pi comes up, but one specific place it comes up is in the ratio between the circumference and the diameter of a circle. Okay, so basically the ratio of the circumference to the diameter is the same for every circle. Okay, and we use pi. Okay, now it's very important here to recognize that pi, everybody's heard of pi being 3.141519 and so on and so forth. We can talk about 3.14. I think most of you are used to using it, but here's kind of one that maybe none of you have never used it as. And this is a good number to know, 22/7. It's actually more precise, okay? And it's especially good to use this when, if you look at this little thing over here, when the radius or diameter is a multiple of 7. And the reason is because if I'm multiplying, like I'm going to be doing down here, right? If I'm multiplying pi times a diameter that is multiple of 7, then I'm going to take 22 over 7, let's say times 14, right? I'm multiplying. Well, what do you guys notice that now that I can do, which is I can factor out a 7 here and make my life easier. Okay, so just remember that when you're going through these. You don't have to. Calculators are loaded up. You can always use 3.14. The book might count it wrong if they're expecting you to use the 22 over 7 for that particular problem. So keep an eye out for a diameter or a radius of that is a multiple of 7. So 7, 14, 21, 28, etc. Okay, so these are our formulas. The circumference is equal to pi times the diameter. Okay, so this number pi times the diameter. Okay, all this fancy thing means is if diameter is 2 times the radius, then you can also write it 2 times the radius with the pi in the middle. Don't ask me why they do that. I guess because it looks cooler. But that's all. These are saying the exact same thing. It's just instead of using d here, they're using 2 times r. Okay, which 2 times r is d. Okay, so let's do a couple. You guys are going to get this. This section's fun and easy. All right, so let's look over here at this shape right here. Okay, this is looks like a skeet disc. I'm a skeet shooter, so pretty sure that's what that is. Maybe not, could be wrong. Okay, find the circumference of the flying disc. The circumference of the flying disc. Use 3.14 for pi. It even tells you which one of the two to use. Okay, so let's do that. So always in geometry problems, write the formula first. It helps you memorize it. Okay, since they're using the radius here, okay, since they're only giving us the radius instead of the full diameter, you have a choice. You can either use this formula here. I tell you what, I'm not going to. I like to keep it simple. You can do it however you want. I like pi times diameter. It's always very easy for me to figure out what the diameter is. I just multiply this times 2, okay? So circumference is equal to pi. Let me do that a little better. I have a bad angle here. Pi times the diameter, okay? So the circumference is equal to, they told us use 3.14, and now we're going to multiply by 10. 3.14 times 10, well, we know, hopefully, from the percentage chapter, when you multiply by a number ending in 0, or by 10, 100, whatever, that we're just going to move the decimal one place. So I don't even need a calculator here. I just move my decimal one place to the right because I'm multiplying, and I get 31.4. And it even tells us right there that that's correct. So the circumference of this is 31.4. Okay, they're all very easy like that. Okay, let's do B really quickly. Okay, so circumference is equal to pi times diameter. And again, if you guys want to use the radius, you can use 2 pi r. That's totally fine. Mix it up so that it helps you remember both formulas. But just so you know. So, okay, so in this one, we have a diameter. As you can see, it goes all the way across. So we have a diameter of 28. So 28 is a multiple of 7. That's why they want us to use this, 22 over 7 in this case. So C equals 28, or it should have been the other way around, but whatever, times 22 over 7. Okay, so now our circumference is going to be equal to, well, let's factor this out. So we can factor out a 7. 7 divided by 7 is 1. 28 divided by 7 is 4. 4 times 22 is 88. And we're done. Okay? So, and there's our correct answer. Okay? All right. So now, this next section, do not think this is hard. It is not. So if I asked you what was it just from this part of it, this is called a semicircle because it is half of a circle. It looks like this. Okay? The only difference is it's the exact same formula, so forget the 2's are down here. It is pi times d. You just divide it by 2. Okay, it's really that simple. You can actually treat this like it's a whole circle. Okay, so pi times 6, and then divide that by 2. Okay, so let's do that. So this, and if you want, you can write it. This c over 2 is the formula saying a semicircle is equal to pi times the diameter over 2. Okay, so therefore the circumference of my semicircle is equal to pi, which in this case 6 is it is not a multiple of 7, so we'll say 3.14 times 6, and then we're going to divide that by 2. Okay, so now on this one I am going to use a calculator. So 3.14 times 6 divided by 2, and therefore my circumference divided by 2, or the circumference of this part and this part. Okay, it's important to understand that that is what it's giving me. Okay, it's giving me this circumference. Okay, their circumference of half of the circle is 9.42. Okay, now that's a weird number, so let's go ahead and check ourselves. I'm using my check here. I haven't done these in a year. I want to make sure I'm telling you right, and if not, I probably will delete this and you would never know. Oh, there it is. 9.42. Okay. So, yep, don't doubt yourself just because the number's bad. Let's see, what else? I think that's really about it. I think this section is going to be easy for all of you. I really do. If you're having problems, message me. I am feeling better. I'm pretty sure I actually did have the coronavirus, which is crazy, but I'll be available this week. I feel much better. I'm awake. I'm alert. So what I want to do is, if you want to get on a Zoom call just to work on something, what I need from you guys is to pay attention to your email. So if you email me and say, hey, can we get on a Zoom call, I'm probably going to get that quickly, and I'm probably going to reply maybe with either an invite or with a time, within the next 10, 15, 20 minutes. Okay, so pay attention to your emails. I had people emailing me last week, and then I'd reply back to them, and then I didn't hear from them for a day. So you have to, when you ask your teacher to get on a Zoom call, make sure you pay attention to your email, because that could be something I could do almost immediately if I happen to be just sitting there. If I'm gone, if I've left for a minute for some reason, then we'll schedule it for a different time. Anyway, I hope you guys had a great Easter.